Okay, here we go. Last lesson before spring vacation and rounding out our solving equations. So we've been solving equations this last part of the unit. We solved exponential equations by converting them to logs. We solved logarithmic equations by converting them into exponential equations. And now we're going to solve radical equations. So lesson 8, we were just kind of working with remember those fraction exponents, the rational exponents, and converting them into radicals. And we've had these kinds of problems come up a couple of times. And I told you that I would show you how to do them later. Here it is. Here's later. So success criteria, I can use properties of radicals to solve radical equations. So the radical means the root. So an equation that involves a root. And then I can check for and identify extraneous solutions. So I will show you what extraneous solutions mean. And there's a couple different kinds of radical equations that we're going to be solving. These first two are the easier kind. And that is if you have a radical on both sides that have the same root. So remember we talked about an index, which is the number of the root up here in the corner. And if there's not a number, that means that they are both a square root. So if you have a root on or a radical on both sides without anything else outside, so there's no extra number out here, added or subtracted, there are no numbers multiplied in the front, then these are the easiest, most straightforward type. So roots and exponents are inverses. They're opposites. They undo one another. So to undo a square root, you would square it. So I would square that side to undo a square root, which is only legal if we both do it on both sides, which is good because I want to cancel a square root on both sides. So a square root and a square are inverses. They undo each other, and I'm left with 5x minus 9. On the right-hand side, a square root and a square are inverses. They undo each other, and I'm left with 3x plus 13. And now you just have an algebraic equation to solve. So I'm going to subtract 3x from both sides. And then add 9 to both sides. 3 plus 9, I'm going to screw that up like I did before, is 24. And then divide by 2, so we get x equals 12. And you need to check your solutions. So if I put 12 in here, the square root of 60 minus 9 is 51. Does that equal, to check it, we're trying to see if it actually works. Does that equal 3 times 12 is 36 plus 13? How did I screw that up? And then I'm going to add 9 to both sides. So 2x equals 22. And divide both sides by 11 or by 2. So x equals 11. And then we need to check our solutions. So if I substitute 11 into this side, I get 55 minus 9 is 46. Is that equal to, because when we check, we're seeing, is that equal to 3 times 11 is 33 plus 13 is 46. Yep, those are equal. We're good. It checks out. So the second one, now it's a fifth root. So to undo a fifth root, we're going to use the fifth power. Whatever the index is, that's the root. The inverse of that is that power. So inverse of a fifth root is a fifth power. So again, fifth root and fifth power undo each other. So I'm left with x minus 7. On the right-hand side, fifth root, fifth power undo each other. 4x minus 22. And I'm going to solve. So if I subtract 4x from both sides, negative 3x minus 7 equals negative 22. And then add 7 to both sides. And if I divide by 3, I get x is equal to 5. So when I go to substitute it in, I get, when I'm checking it, I get the fifth root of negative 2. because 5 minus 7 is negative 2. Is that equal to the fifth root of 4 times 5 is 20 minus 22 is negative 2. Now, previously, we haven't been able to take a square root of a negative number, right? That's because square root means you multiply something twice. And if you multiply two numbers, you're always going to get a positive. This is a fifth root. So if I multiply 5 of something, I could get a negative number. So if your root is odd, if your index is odd and your number inside is negative, that is totally okay. Okay, so the second type of problem is to solve an equation that only has one radical in it. And this is where it's a lot more like the exponential and the logarithm equations that we were solving before, in that we follow those kind of same steps. Remember that first step is always to isolate the thing, whether it's an exponent or a log or a radical, you want to get that thing on that side all by itself. So anything else we would move to the other side. This first example doesn't have any numbers that are outside the radicals, so that's already isolated. But if you look like at this one, this minus 13 that's not under the root, we would want to move that first. On this bottom left one over here, this 2 that's not inside the root, we would want to move that first. Anything not in the root, you want to get rid of as your very first step. So since this first problem, that is already done, second step is to use the appropriate exponent to cancel the radical. So like up above, this one, if it's a second root, we need to use the second power to undo it. What we do on one side, we have to do on the other. So I have to do a second power over there. So second root and second power undo each other. I have 2x plus 5 is equal to 3 squared is 9. So I'm going to subtract 5 from both sides. 2x equals 4. I subtract 5 and subtract 5, and then divide both sides by 2. So we get x equals 2. Excuse me. And again, we have to check. So 2, if I put 2 in for the x, 2 times 2 is 4, plus 5 is 9. Does the square root of 9 equal 3? Yep, we're good. The second one over here, again, anything not in the root, we're going to move first. So I'm going to add 13 to both sides so that I'm isolating this radical. I'm going to isolate the cubed root of x minus 6 equals, if I add 13, that will cancel, add 13 over here, and I get 1. This time it's a third root, so the power to undo it will be the third power. Do it on one side, I have to do it on the other. So these cancel, and I get x minus 6 is equal to 1 to the third is 1. And then add 6 to both sides. So x equals 7. If I check it, 7 minus 6. 7 minus 6 is 1. Cubed root of 1 is 1. 1 minus 13 equals negative 12. So check, it worked. This would be a great place for you to pause the video and try these next couple. They are the same types of problems, similar types of problems. So you trying them would be a great thing right here. Okay, so on this one, the 2 is not inside the radical, so I want to move that first. It is being multiplied by the radical, and the opposite of multiplication is division. So I'm going to divide this side by 2. That will cancel that out, and then I also have to do it on the other side. Divide this side by 2. So now I have the square root of 3x plus 40 equals 5. This is a square root, so to undo it, I'm going to use the second power and then do it also on the other side. Root and power undo each other because they're inverses. So 3x plus 40 equals 25. If I subtract 40 from both sides, I get negative 15. And then divide by 5, or divide by 3, x equals negative 5. So we have to plug that back in there to check. 2 times 3 times negative 5 is negative 15, plus 40 is 25. So square root of 25 is 5, times 2 is 10. Yep, we're good. Last one on this page. Do good. 12 is outside the radical, so I'm going to begin by moving it, by subtracting it from both sides. So if I subtract 12 here, then I have to subtract 12 on the right-hand side as well. 20 minus 12 is 8. This one also is a square root, a second root, so I'm going to use a second power to undo it. Second root and second power are inverses. They cancel each other out. And 8 squared is 64. So subtract 54 from both sides, and we get 10. Divide both sides by 2, and x equals 5. So if I put it back in to check, 2 times 5 is 10, plus 54, that's the square root of 64. Square root of 64 is 8, plus 12, yep, 20, we're good. So far they've all worked. Don't get complacent. Okay, so now we actually have to talk about extraneous solutions. Extraneous solution means when you solve an equation, you get it as an answer, but when you plug it back in, it does not work. And that happens sometimes. Sometimes it happens in real life problems. It just does, particularly with radicals. So these are also a little more difficult because notice this is a square root, right? So I'm going to have to square this side to cancel the square root. I'm also going to have to square this other side. And when I square this side, we're going to have to be careful. So square root cancels with a second power. I get 9x plus 10. Okay, here's where we're going to have some mistakes happen. Remember back from when we did polynomials, when you multiply this, you cannot just square both things inside the parentheses. That does not work. Squared means that you have 2 of them that you're multiplying. So I'm multiplying an x plus 2 by another x plus 2, and we have to distribute that all out, otherwise we miss a number. So we get x times x is x squared, x times 2 is 2x, and then we distribute the 2 through as well. 2 times x is 2x, and 2 times 2 is 4. And then we can combine like terms, so we get x squared plus 4x plus 4. So this one's not quite as easy to solve because we have an x squared in there. This is a quadratic, and to solve quadratics, you need to get it set equal to 0. So I need to subtract 9x from both sides and subtract 10 from both sides so that I have it equal to 0. So if I subtract 9x here and here to get rid of that, and then I'm going to subtract 10 and subtract 10 from the 4. So 4x minus 9x is negative 5x. 4 minus 10 is negative 6. So we have a quadratic that you need to solve, and this is going to depend on your level of comfort. I prefer to factor them. We've made them all so that they factor, but some of you really, really don't like to factor, and if you don't, then you have to do quadratic formula. I don't want to do it because that's long. So I'm going to factor, and I know that when I'm factoring and there is a coefficient of 1 in front, I look for 2 numbers that multiply to the last term. So they're going to multiply to negative 6, and add to the middle number. So they're going to multiply to negative 6 and add to negative 5. Those two numbers are -6 and a +1. Okay. Remember, our whole goal here, like this is a lot. Our whole goal is to figure out what x equals. So what can I put in for x to make this equal to 0? Well, to make this one equal to 0 would be a -1, because -1 plus 1 is 0. And to make this one equal to 0, it would be a +6. 6 minus 6 is 0. So I get two possible answers. I need to go back up to the top and check both of them. They could both work. Maybe one of them works. Maybe neither of them work. So we have to go back up and check. Okay, so the first one, I'm going to put -1 in there. So 9 times -1 is -9 plus 10. I don't know why I made that so big. Actually, I'll put the whole thing. So I get -9 plus 10, and then equals -1 plus 2. That square root of 1 is 1, equals 1. So that works. I also need to check 6. So if I put 6 in here, that's 54 plus 10 equals 6 plus 2. 54 plus 10 is 64. Why did I write that? You guys, I'm losing my mind. I forgot a plus 2. Okay, so 54 plus 10 is 64. Square root of 64 is 8. 6 plus 2 is 8. Both sides equal 8. It checks out. So these are both solutions. This one has two answers. Let's look at, I think we got two more. Okay, isn't that one fun? Let's try another one of those. You will only have these with a square because we're not going to have you do anything but that. So we're going to square this side to cancel out the root. We get 2x minus 5. And then we have to square this side because if we square one side, we have to do the other. And so I have to multiply this all out. You might get to the point where you can do it without writing it over here, and that's okay if you can do that. So x times x is x squared. X times -4. And then -4 times x. And -4 times -4 is +16. So if I combine those middle terms, I get x squared minus 8x plus 16. Okay, so I have an x squared, which means I can't just like move everything to one side and solve it because it's a quadratic. To solve quadratics, we need to get them set equal to 0. So I'm going to subtract the 2x from both sides, and then I'm going to add the 5 to both sides so that I can get 0 on the left. So I'm going to add the 2x. Oh, sorry, subtract the 2x. I'm messing up a lot today. It's Friday, I'm tired. Subtract 2x from both sides. I'm going to add the 5 to both sides. Okay, so over here I have 0. That's what I want for a quadratic. I want it equal to 0. Equals x squared minus 10x plus 21. So as long as your coefficient in front is a 1, which that's all it's going to be for this lesson, we're not giving you anything else, okay? It'll always be a 1 for this unit. We are looking for two numbers that multiply to the last number, so multiply to -21 and add to the middle number. So you need two numbers that multiply to 21 and add to -10. They are -3 and -7. So our solutions for x, remember we're trying to get it to be 0. What makes this equal to 0 would be a +3. 3 minus 3 is 0. What makes this one equal to 0 would be +7. 7 minus 7 is 0. And then we're going to check. So we'll check the 3 first. 3 times 2 is 6. And then 3 minus 4. So 6 minus 5 is 1. Square root of 1 is 1. On the other side, I get 3 minus 4. So here I get 1 equals negative 1. That is not true. That does not work. No. That means that that number that I plugged in, when I plugged in 3 to test that and it did not work, that is not a good solution. That is called extraneous. So 3 is extraneous. It's an extra one that doesn't work. You still need to check 7 because it's possible that one does and one doesn't, or maybe they don't. Both don't. So you still got to check 7. So when I put 7 in here, I get 14 minus 5. And then on the other side, 7 minus 4. So square root of 9 is 3. 7 minus 4 is 3. That one checks out. So my only answer for this problem is 7. Because it worked. 3 did not. I know these are long. I know these are far more challenging, right? Because now all of a sudden you have to remember all of that quadratic stuff that we haven't done in a while. But still, it would be a good place to pause this one and just see how much you can do, see how far you can get. And then if you get to a place where you're stumped, then come back and start the video up. Okay, so I'm going to square both sides to get rid of the square root. 61 minus 10 squared, 10x equals, on this side, x squared minus 14x plus 49. And I got that by, you would have to do 2 of them like this and distribute it out. That's how you'd get this. I want to set it equal to 0. So I'm going to subtract 61 from both sides and add 10 to both sides. So I get minus 4x. And then 49 minus 61 is negative 12. Okay, so since my leading coefficient is 1, my a is 1, I'm looking for 2 numbers that multiply to negative 12, add to 4. Be careful, don't just willy-nilly throw stuff out like, 3 times negative 4 equals negative 12. You have to make sure they add to negative 4. So it would be negative 6 and positive 2. Which means that my solutions for x to make it 0 are positive 6 and negative 2. And then did you remember to check? If I substitute 6 in there, I get square root of 1 is 1. 6 minus 7 is negative 1. That does not work. 6 is not a solution. If I test negative 2, because negative 2 will work, right? Because if the first one didn't, the second one surely will. I get 61. Negative 2 times 10 is positive 20 equals negative 2 minus 7. So that's 81. Square root of 81 is 9 equals negative 2 minus 7. Oh, nope. That one did not work either. So in this case, they are both extraneous. That means that nothing worked because both the 2 answers that we got when we solved it were extraneous, didn't work. So that means that this one would have no solution. There was nothing. Whew. So if you're still struggling with factoring, this one's going to be a rough one. You are free to use, once you get to here, to use quadratic formula. Again, I don't like it because I like quadratic formula, but it takes longer. So if you can factor, that for sure will save you some time.